All right, hello everybody. I'm trying a different thing today. Somebody showed me how to do a movie recording and a screen recording at the same time. I'm hoping it'll work out. Okay, so today's video we're just going over our trig transformations, and before we get to that we need to review some of our regular parent function transformations. So if this was our parent function, we'd have an a, B, a C, and a D. And it looks like I forgot parentheses right here. Let me make that a smaller line and make it black. Looks like there's a parentheses that got left off there and there. Alright, so now B is outside of the parentheses. So if this is our parent function, then the A, if the A was a fraction between 0 and 1, then it's going to shrink it vertically. So it'll take your graph, hold on, there we go, and it's just going to get smaller this way. If A is greater than 1, you're stretching. So hold on, there we go. You take your graph and just pull it apart this way. It ends up looking like it's skinnier. And then if it's if it's less than 0, so if A was negative, then it would reflect across the x-axis. All right, and then the B values. B will stretch horizontally if it's a fraction. Between 0 and 1, you're stretching here. And then if it's greater than 1, it compresses horizontally. So you're like, hold on, there. So you're either stretching it out this way or compressing it back together this way. And then B, negative B would reflect it over the y-axis. And I know we really didn't do a lot with stretching, compressing, and reflecting of the B value when with our other parent functions. I will tell you with transformations you do a lot with this B value. All right, let's move on to C. So if your formula says x minus C, then you're shifting the graph to the right. If it says x plus C, then you're shifting the graph to the left. And then your D value here, it's just moving it up and down. If D is positive, it's going up. If it's negative, it's going down. So that was the very quick review of parent function transformations. Now, let's compare those to your trig function transformation. Guess what? There's not a whole lot of different things. You still have your A value, your B value, your C value, and your D value. And if you notice, if A is a fraction, it still compresses vertically. If A is a number greater than 1, it stretches. If it's less than 1, it reflects. Okay, it's all the same process. You're just dealing with a trig parent function instead of a x squared or like a radical like the square root of x or whatever. All right, so we're just dealing with trig functions. They're going to transform the exact same way, exact same rules. Okay. Some things that are different though are the vocabulary terms. Okay, find this page on your notes and you need to fill in everything that's in red. Okay, so A, not only does it stretch or compress vertically, it also tells you the distance from the sinusoidal line. All right, I know it's called sinusoid. On your sine graph, it's the line that's right halfway in between your minimum and maximum points. Okay, so this distance here would be A. Okay, this distance from here and here would also be A. And this is a distance, so it's just going to be the absolute value here. Okay, if it's negative, then your graph is just going to reflect across the x-axis. All right, so that's your A value. You're still stretching or compressing. If you have an A that's really big, then maybe it goes up and down really far apart. Okay, that's basically all that A does. Same type of transformation. Now your D value at the very end is still going to shift up and down. But what that actually shifts is the location of the sinusoidal line. Okay, normally that sinusoidal line is at the x-axis. Okay, normally without doing any transformations, that is at the x-axis is the sinusoidal line. So that's what you might want to write that down, that normally that's what the location of the sinusoid is, on the x-axis. All right, and then let's see, I probably need to erase this so I can move it up. Now let's look at your B and C value. Okay, remember with sine and cosine, your period length is 2 pi. Let me erase the rest of this. Okay. So we'll get into frequency and how your B value affects the period more in class. For now, you just need to know that if B is a fraction, or sorry, if it's greater than 1, you're actually shrinking, you're doing the opposite, and then if it's a fraction, you're stretching. So what happens is normally your sine or cosine graph may look like that. Well, if you stretch it, your waves get farther apart like that. If you shrink it, your waves will get really close like this, okay? So that's what your B value does. It stretches or compresses your sine and cosine graphs horizontally. Think of a slinky. Think of stretching a slinky or compressing a slinky. Okay, that's what the B value does. I'll explain more on how to calculate it and how to calculate the frequency as well in class. For now, you just need to know that that stretches and compresses horizontally. Your C value, again, it shifts left and right. And again, if it says x minus C, then you're moving right. Okay. If it says x plus C, you're going to the left. And that's the same way all your other parent functions are moving. Okay. Sorry. So, same as everything. If it's a number that's in here inside the parentheses, then you're moving left or right. Okay. So the B value is used to determine your period length, which is the distance in the x direction required to complete one cycle. Okay, your period length is just one cycle. Frequency is equal to the reciprocal of the period. So if your period is 2 pi over B, then your frequency is B over 2 pi. So here the frequency formula would be whatever your B value is divided by 2 pi. I'm talking you through this in the video. I will tell you, at the high school level, pre-cal high school level, we really don't do a lot with frequency. But in physics, you probably cover this, and in your college pre-cal, you will cover it. Okay. Let's see, the location where the period begins, yada, yada, yada. All right, so that's it. Hopefully it was nice, short, and sweet. We will get through the rest of this in class. Let's see. Yeah, we'll go through some examples in class. Just make sure you have these notes filled out. Make sure you review your parent function transformations from Algebra 2 and Algebra 1. All those from parent function transformations, you need to know them. All right, I will talk to you later. Bye.